So how are you, Andy?
I'm all good. Yeah, I'm all good. The sun has been shining today, so it's all good. Things are okay, and hopefully things are easing. The worst part of the whole lockdown's behind us, and we can, albeit probably very slowly, very cautiously, start walking towards something a bit more, something a bit better.
Definitely. See a few more people joining us now. A very warm welcome to you guys. And tonight's talk is going to be on exploring inner space. So what's that going to be about, Andy? What's
So,
inner
okay.
space about?
Yeah. So the talk, it's going to be, I do a lot of things, and actually I got involved in space through a mutual friend of ours who works at for the UK space community, and that was actually through skydiving. But the thing I do most of, the thing I do best is diving. And I've always drawn this sort of analogy between the underwater world and how alien and hostile it is to survive there, and going to space. It's an amazing place, much like space, but you have to have the right skills, the right equipment to go and explore these places. And there are a lot of similarities between the equipment, which I'll come on to later on, and the skills and the sort of attitude towards risk and how we deal with that between the sort of underwater world and the world of space.
Yeah.
So yeah, we're going to basically touch on some of that, and then just some examples of some of the places that I've been and explored to sort of look at that inner space world, that kind of, I think, that alien planet that exists on our own planet, just under the waterline.
Yeah, I think we mentioned it earlier on Instagram, didn't we? That I think we know more about outer space than we know about the inner depths of our planet.
Yeah, so this cliche that we've surveyed more of the surface of the moon than we have of the floor of the ocean. You see, being true, because the moon's not that big, and the Earth's ocean is vast, and it covers like over 70% of the Earth is actually water. And I always thought this interesting that there's a Korean symbol which means heaven and earth. It's basically there's the very version of yin yang, and heaven is red and earth is blue. I always thought it quite nice that because some people think of earth or green or brown, but actually, if you look at the planet Earth, most of it is blue. And actually, it's very hard to survey. It's we've got Google Earth and Google Maps and satellite imagery, but those don't penetrate the surface of the water. So there's a vast amount of Earth that's completely unexplored.
Yeah,
because it's all.
Yeah, I mean, growing up watching David Attenborough's videos and documentaries, it was all you learned so much about deep space, but when you think about and put it into perspective, it's not actually that deep they go.
Going to fix that. Yeah, I mean, well, you don't need to go that far. I mean, most of life as far as biodiversity, even biomass, is in the first 10 meters, really, because the sunlight is. It's the coral reefs, that's where all the animals, and even the ones that live at depth, often come up to that area to feed or at night. But life goes all the way down. We used to think that the benthic areas, the place at the bottom of the ocean, the deep parts. I don't mean the seabed offshore. I mean the seabed, like the Marianas Trench. These are kind of abyssal plains, were completely devoid of life because they're like, people assumed they were like the surface of the moon. Nothing would live there. And then they start sending down remote cameras and obviously bathyspheres and little submersibles and submarines, and realised that actually there is millions of different species down there, and probably the most alien-looking creatures in the world. Those, if you want to see a proper alien sci-fi, monster, you just got to go to the deep ocean. So I think, and even now the point where more and more people, I think, are recognising and accepting that the Garden of Eden, if you will, the sort of birthplace of life on Earth, wasn't on land in sunlight, and actually it started in the deep hydrothermal vents, with animals that live completely without sunlight. That's probably where the first kind of primordial life began. So,
organisms were, yeah. Awesome. Yeah, I mean, I just want to say hello to everyone else who's joined us.
Hi.
I see Freddie Holding. Hi to Freddie. Hi, Ryan, Michael, Joseph. Really nice of you guys to join us. Just to let you guys know, we'll be starting in about 30 seconds.
Ooh,
and I'll let Andy take it away.
Thank you.
But welcome to everyone. I hope you guys really enjoyed the talk. So I'll be here if you need anything throughout, and then around 6 o'clock, we'll start a Q&A session. We'll see how it goes, and then to everyone watching, feel free to throw in your questions throughout, and then we'll see if we can try and fit them in. But definitely we'll take a look at them at the end. Awesome.
Okay, we'll begin. I often ramble on and go off in tangents, so 6 o'clock might be a bit ambitious, but we'll see how we get on. What is now? Well, 6-ish. Anyway, we're in lockdown. You probably know where else to be. Although I have kids to put to bed at 7 o'clock, so I do have a hard stop at some point. So yeah, if you've just joined us and you missed the sort of chat I was just having, my name is Andy Torbet. I do a lot of stuff, but one of the things I do, the thing I do most often is I'm a diver and an underwater explorer, which sounds very grand, but I'll come on to how pretty much anybody can be an underwater explorer towards the end. And often I draw these analogies between space and being underwater, and that'll be a thread I'll be revisiting throughout the talk. But first of all, I just want to bring you back in time a little bit to when diving first began, because just like, the birth of kind of split space exploration was within, living memory, really. Only a few generations ago, we really started to explore underwater, and admittedly, there's been people going under the sea for roughly, thousands, tens of thousands of years, and people back into medieval times and Leonardo da Vinci had all these sort of setups where they were trying to create sort of diving suits, but really the first proper diving suit was back in the Victorian times, kind of like mid to late 19th century, with these sort of big brass helmets, brass boots, brass kind of plates that to weigh you down, you walk along the seabed. But actually this shot is from 1935, and it's really the first proper cave diving exploration. So cave diving was basically invented in Britain and by a team of people, and the first two divers were these two, Graham Balcom and Margaret Powell. So the first two ever cave divers in the world was a one man and one woman, and they were diving at a place called Wookey Hole in Somerset, right here in the UK. And I had a chance to go and basically reenact that with the original kit a couple of years ago. I can tell you this stuff is not designed for cave diving. You basically have to drag yourself along the floor of the tunnel and trying to smash your head on the surface as you go. But the equipment, much like those first spacesuits when they were firing dogs and monkeys up into the air to try and test them out. The underwater world, the technology has advanced a lot since then, and this is one of the. It looks probably fairly similar, and looks like a big, chunky armored suit. This is the Ocean Works hard suit. It's what's called a one atmosphere suit. So, although it looks like an armored spacesuit or Buzz Lightyear costume, it's basically a wearable submarine. So you can move your arms and your legs, and you've got a big sort of propeller pack that can thrust you around underwater. But you're held at one atmosphere the whole time, i.e. you're held at the same pressure that you and I are at right now at sea level, because normally when you dive deep, you're subjected to these massive pressures. So later on, I'll talk about a dive I did to 120 meters, and at that sort of depth, you are 13 times the pressure that we are at right now. Assuming you, like me, you're not watching this from a submarine somewhere, and if you are, that's very cool. Let us know in the comments. But yeah, this thing can go. This operational depth is 600 meters, which is just incredible. And it's a phenomenal bit of kit. I had a chance to train on it and dive it. And this was out in Vancouver in their test pool. It's a phenomenal bit of equipment, capable of going 600 meters deep, over half a kilometer deep. But I was using it for a children's BBC show, which was great. But now bear in mind, this is a cutting edge ocean exploring equipment, you know, phenomenal capability and costs tens of millions of pounds. And what I did with it was release some toy crabs from a pirate's treasure chest. That was what I did for with my amazing bit of diving equipment. But things aren't always like that. Admittedly, sometimes, you know, I've been doing sort of free diving projects and filming sort of projects as well. This was diving with shark fin makos off the coast of California and Mexico. Free diving with them, and these guys are capable. They're the fastest shark in the world. And we're looking not only at the speeds they can do, but how high they can jump out of the water. And they even record it breaching, which is when they jump out of the water, over 9 meters high, which is just phenomenal for a shark that's only slightly longer than me. The same project, looking at the mako sharks and the speed they can swim, gave me the chance to use some new technology. And again, it's the thing about how the diving is so similar to space, is that it is a wholly alien environment. There is nowhere on Earth, forget the North Pole or the South Pole or top of Everest, there is nowhere that we as human beings are less able to survive than underwater. You know, even if it's in Garden Pond. We are wholly reliant on the equipment and the skills and experience we've developed to keep us alive. So, you know, new technologies are really important. These, you can just make these out. These are tiny little, basically, underwater sort of propulsion systems. There's little propellers on your wrists, and the idea is you sort of basically have a little trigger here, and you press the button, and the motor start up, and you can fly like Iron Man underwater, like Aquaman meets Iron Man. Which I'm aware, for the geeks among us, and I include myself in that, that is DC and Marvel crossing over. So, you know, allow me a bit of slack. But on my back is a big battery. It's like 2 car batteries on this little rucksack I've got on my back. It's great fun to use, but with a few problems with it. In that, at one point I was underwater and they stopped working, and clearly I had about 12 kilos of negative buoyancy, so 12 kilo weight stuck in my back, and about 20 meters depth at the bottom of this big swimming pool in Italy. I was like, they could stop working. I had to try and swim my way back to the surface with this weight in my back. I only just made it, and I surfaced, and the cameraman was there in my face, and the director was like, "Okay, Andy, how's that?" And clearly my response was not broadcastable on children's television, needless to say. Now, as far as technology goes, one of the we often do quite, especially in cave diving, quite expeditionary kind of, just trying to get this light so you can see that a little bit better. That hopefully shows up a little bit better. This was a project out in Greece, the filming, and there was some science and archaeology going on at the same time, on a ship called the Britannic. And we're out there middle of June, Greece in the summer. It's very, very, very hot, but you still got to put on a big thick woolly undersuit and a big rubber suit, dry suit over the top of that to keep yourself dry and warm, because even though the water was kind of 20 degrees Celsius on the surface and about 16 degrees Celsius in the bottom, which is really warm, especially for somebody who dives in the UK. If you're spending 6-7 hours underwater, you will eventually start getting cold, because water conducts, it sucks away heat from you at like 25 times more than air. So our bodies are 37 degrees Celsius roughly. So anything below really, 32, 33, and eventually you'll get cold. So that's why we wear all this insulating kit, which is great. But when it's on the surface, when it's 40 degrees Celsius and you've got all this kit on, you are properly hot. So this was the aim of the project. This was Britannic. This is the sister ship of the twin sister, really, of Titanic. I'm just keeping to adjusting the light, just so you can roughly. It's more important you can see the screen than me, because the pictures are far more interesting and far more attractive than I am. So yeah, Britannic was the twin sister of Titanic. In fact, she was improved because she was still being built by Titanic when Titanic sank. So they put effectively more armor on her, more safety stuff, and more lifeboats, which was important. And she was used as a hospital ship She was never actually used as an ocean liner. She was seconded into the war effort in World War One, and did many successful voyages, but unfortunately off Greece hit a German mine and sank in 1916, which is a fair one because, I mean, these huge sea mines were designed to sink battleships, so she didn't stand much of a chance. But the technology we used in this trip was phenomenal. It's more than anything I've used in the past. We had this amazing research vessel out of Malta, a Russian-owned research vessel. And on board was a one-man submersible. There was a two-man submersible on there as well. Sorry, three-man submersible on here. We had this massive ROV, so a big camera system with lights and all cabled to the surface. It's big, sort of basically an ROV is a remote operated vehicle. So basically, imagine a camera with lots of tools and that, a robot, it's an underwater drone basically. And then this, the wet bell. I love this thing. So a wet bell is a place where you can get in and decompress comfortably. What it means is that underwater, you can just see you dive into it, but this part up here, you can maybe just make it the water line there, this bubble underwater, is you can get up there and sort of take your mask off and even your loop out, potentially your mouthpiece out, and eat and drink, which is important when you've got perhaps hours and hours of decompression to do. Because, and I'll just show you that this, you see that little bubble? So the water line's up to my chest there. And it meant that you can chat, you can take some eat and drink and talk to the surface. And this, if you imagine what it basically is, if you've got a glass, okay, and a bowl of water, if you turn the glass upside down and plunge it underwater, the glass won't fill with water. There'll be air trapped in the glass underwater. It's exactly the same system. It's important because if we did an hour at 120 meters, and that's how deep this wreck is, it would take around about 6 hours to come slowly back to the surface. You have to do that to decompress, otherwise the bubbles that you've absorbed at depth fizzes up in exactly the same way as would happen if you shake a Coca-Cola bottle up and then take the top off very quickly. That's what happens to your body. So we didn't have a huge amount of luck. We were out for 10 days. We didn't have a huge amount of luck, but on the 10th and final day, we went and dived at all up at this point because of the winds and currents. We finally had a chance to get in after sitting all kitted up, ready to go, in all this heavy rubber kit in the heat for hours. You can see I'm pretty red-faced there, which is not the normal colour of a bloke from the Highlands of Scotland. We're finally able to jump in. So here we go.
Let's go. Everything changes as we leave the world of air and enter the ocean. Deep sea diving is the closest thing on Earth to exploring outer space. This line will guide us to Britannic. The subs and the robot cameras will light our way in the darkness when we're 400 feet down. And then, out of the gloom, she appears. Britannic.
So there we go. That's this little clip from the BBC series that we did. That was me voicing over, by the way, on tape, not me chatting to you as it was. But that's what Britannic looks like today. Actually, incredibly well preserved and really intact. This is where the mine struck, just there on the port side. But yeah, you explore this thing, and again, it's enormous. It's 900 feet long, this thing, by the way, and it's 100 feet from the ocean floor to the top bar here. So this is huge shipwreck. But as you dive in it again, you really do feel like this kind of an ocean explorer. And one of the problems, you can just see these two little divers here in the submarine. One of the problems you have, both in caves and very deep wrecks, because they are so deep, is that it's dark down there. You know, it is, and in a cave it is absolute zero light. It's properly black, just like space. So you have to take your illumination in with you. And it's often difficult with a big wreck like this just to appreciate how big it is and to see it properly with your little torch that you've got. But luckily, we had these movable floodlights in the form of the submarines that would come along and just light up these massive stretches of the wreck for us, which made filming and exploration just so much better. But again, as you sort of hung this tiny diver down here, but then the big sub there, it looked to me as a diver much more like how I imagine an astronaut on a spacewalk would look at, you know, a spaceship in the darkness. This huge thing with the arms and sort of, it's all a bit like a flying saucer dome and the bright lights. So yeah, this was pretty incredible.
This is the bridge where Captain Bartlett stood that day. Incredibly, the tiles are still on the floor from where the ship was steered. Though it's becoming a man-made reef, if you look carefully, you can see the steering gear underneath. And if you rub a little, you can still find the glass of the telegraph that Captain Bartlett used to send orders to the engine room. But time has taken its toll. It's only thanks to the wood and walls rotting away that the most astonishingly intimate relic has been revealed. Captain Bartlett's bathtub. He was the last man to sit in it, and the plug is still in.
There you go. 13 times atmospheric pressure, and that's what does your brain. You appreciate bathtubs more and more. But it is, the level of preservation is incredible. And this shipwreck, like many others, you know, we may see as kind of rubbish that we've dropped in the ocean, but in the case of a lot of these places, they've actually become artificial reefs, become kind of oasis for wildlife. You know, life finds a way to kind of make the best of these things. And I should say one thing, it came time to leave, and I thought, great, so I'm going to go back to the wet bell, and there I've got my iPod. I've got loads of Sherlock Holmes audiobooks on my iPod, and I've got 6 hours of decompression to do, but that's been nice and comfortable. Listen to my iPod, you know, come out, eat and drink. It'd be nice. We got back there, and there'd been a problem with the wet bell. The current had picked up savagely on the surface, and it become all tangled up. The wires become tangled up. And what's even worse is my iPod, the battery had fried in it, just because it was really old. So from about 90 meters to the surface, which is like, say, 6 hours, we used to slowly climb up this little piece of wire and then hold on this current for hours near the surface, like flags in the wind, and just with nothing to do but just watch our clocks tick by, or the decompression tick down. And I got back to the surface, and because we're filming for the BBC, the first thing that happens obviously is, you know, the camera gets stuck in your face. Top tip, if you ever become a TV presenter and a diver, is that diving's not the most kind of, especially post-dive, the coolest thing. You know, your mask has been on for 6-7 hours, so you get a big mask thing. Your lips a bit swollen from the salt water and holding your regulator in the whole time. And what also happens is you're full of snot. So you pull your mask off and you pull your hood off and you're just like, bah. So quick top tip is to, when they come and stick the camera in your face, is you duck down, pull your mask off, pull your hood up, and give your nose a really good wipe, and then look at camera. And the director said, all right, so Andy, how was it? And I gave him this line, and it was the perfect summation of the whole series, about Britannic, the disaster, the people, and it was delivered like no line I've delivered in my life. And he was like, oh God, that was really good. Clearly surprised, because normally I was terrible. But anyway, that was really good. But what, of course, he hadn't realised is that I had nothing to do for the last 6 hours than basically write and rehearse that line again and again and again and again. So there we go. That's how you get things right. But yeah, fantastic effort, and involving a huge amount of different equipment. One thing I'd like to finish on is what we are both using here, myself and Richie Kohler, my friend who's one of the sort of world's top wreck divers, American guy. We use a thing called a rebreather, a closed circuit rebreather. And that's not like normal scuba gear. What it does is it recycles one breath. And as well as that, we're not breathing air. We're breathing this thing called trimix, which is a mixture of helium, nitrogen, and oxygen, which keeps us alive at depth. If you breathe that mix on the surface, it would kill you. Just like if you breathed air at 120 meters, that would kill you. What's interesting is rebreathers. It's the exact same thing that astronauts use in EVAs in spacewalks. Back-mounted rebreathers, just it's a slightly different system, but exactly the same technology that's used. So going to a bit more moonscape now potentially. This is Store Glacier in Greenland, and I was there again on a science expedition and a filming project at the BBC and Discovery US, and a lot of glaciologists from the UK, from Canada, and the US, looking at global warming and also the process of the birth and death of an iceberg. So it's from its conception up at the head of the glacier all the way down to the calving front, where an iceberg is born. It calves off and is born, and then floats out to sea and eventually dies. And one of the underwater elements we had, I was there kind of as a presenter, but also as the mountaineer and oh, that's okay. It's just Lakshya tell me not to rush to try and finish by 6. Don't worry, my friend. I'm only halfway through. I'm joking. There's some amazing environments in these places that no one has been before. You know, genuine exploration. These are blue lakes. So these are glacial lakes that form in depressions in the glacier. And this one had never been dived, unsurprisingly. You know, a lake on a glacier in the middle of Greenland has never been dived. And we wanted to dive it for a few reasons. You can just see this tiny little, that's me jumping off into the crystal clear waters. If I just do that, you might be able to see it a bit better. There we go, beautiful. And the reason we're doing it is we want to place a sensor on the lake bed that would tell us when the lake emptied, because how they often empty is as the glacier moves, crevasses open up on the lake bed, and this water just pours down this crevasse. It's like a plug hole. All the water goes down this giant plug hole with apparently up to 10 times the power of Niagara Falls. So myself and my friend Doug Allen, who's a cameraman, were to go in there, do a bit of filming, and place this sensor on the bottom. And I should say, I'm going to show you a little clip. And what you'll notice is the sensor is tied to a rock. The reason is that the sensor, which is meant to be placed on the bottom, designed by the scientist, floated. So, and all sorts of ideas were thrown around about you know, the sensor being put in a cradle, made of ice screws, or filled with a resin and blah, blah, blah. I think it was Doug that said, why don't we just tie it to a rock? So the helicopter, because it's the only way to get around in this part of the world, the helicopter flew back to base camp, picked up a rock, and flew back. And then we tied the sensor to a rock. So anyway, here we go. He says, there we go.
It's absolutely beautiful down here. All these shades of white and blue. I'm gonna try and place this sensor here. The sensor will now record any change in depth. Let's have a bit of an exploring. See if we can find where this plug hole is, eh?
So yeah, I thought to myself, since we're here, you know, a little bit of ice cave diving, let's go and try and find this potential plug hole. So off I went.
Oh, Doug, this thing does a big tube here. It goes straight down. Look. This could be the lake's plug hole. Andy, it's a challenge you can't resist.
It's pretty dark in here. It's just getting darker. It's getting too tight.
So there we go. I didn't get that far into that cave, but you would, wouldn't you, if you saw an unexplored underwater ice cave? Of course, you're going to go in. Well, I did anyway. From there, actually, we moved on to the Arctic Ocean. And one of the problems we found there diving around icebergs was polar bears. And you can just see the top of our little boat there, but we actually moved away because that polar bear was about to jump in. If I just turn that, you'll be able to see a little bit better. There's a polar bear just up here about to jump into our boat. And someone said, "Oh, it's okay because the deepest polar bears have been recorded diving after seals, after prey, is 25 meters." To which I said, "Well, that's what they've been recorded doing. You know what they're doing when we're not watching, we've got no idea." But I figured as long as I was always deeper than Doug Allen, I was all right. And I'll show you a little clip of one of the dives, just because it shows you this alien world and some of the alien creatures that you probably aren't used to seeing up close that we can get in the Arctic Ocean and around the world. But in the Arctic Ocean, they're particularly big because of the cold water upwellings that you get in the Arctic. So you see these alien creatures far more vividly, and you can really get appreciation for them.
Go in, ready. This place is stunning. I've never seen walls of ice. The colours are blue and white. It's absolutely beautiful. The surface, this ice wall, it's like tiny little dimples all across it. It's the whole surface. Looks like a golf ball. Can't believe how much plankton there is down here. The size of these things.
Andy's amazed at how rich the waters are around the berg.
Lion's mane.
These creatures form part of the complex food chain that feeds the fish, that feed the seals, and ultimately feed the polar bears.
That's like example. Chris. I should keep him happy. Okay, let's go up.
So there we go. And that last creature was a sea angel, but that's a sort of translucent, like basically snail that looks like it's got wings. And that was part of the inspiration for the alien, well, the creatures that are out in the film called The Abyss. Which if you've not seen The Abyss, go and watch it. Fantastic film. So moving on then to the sort of final couple of things I want to say in our environments, and one is caves. Again, I'm just going to cover this sort of section you really appreciate some of the colours. Now, I do a great deal of cave diving, and it's one of those real frontiers. There's still thousands of miles of unexplored cave systems around the world. Even here in the UK, I've done exploration right here in the UK, up in Scotland, in the Cave of Skulls. We've still got projects going on in France, in Spain, in Germany, in Eastern Europe, Mexico, America. I mean, all around the world. There's not a country in the world that doesn't have sort of unexplored caves, really. And they are. This is like, if I always say that this is like going to the moon, because you're floating through these environments, and it's like usually often limestone, so it's white rock. Again, I just want to give you a chance to see that a little bit clearer. So it's often white rock, gin clear visibility, and you're there weightless, floating through these things in complete darkness, apart from the lights that you bring with you. And it's not just underwater. You get the chance to sort of surface, and in places, again, sometimes where no human being has ever been before. And I say that's not always abroad, sometimes that's right here in the UK. And in fact, we've done plug for space. Actually, never thought of this a plug for space tour, but yeah, you can go, and we did a 360 film, filming in a cave system in France, for VR purposes. And actually, at the space store, you can go to the space store, you can don a set of VR goggles, and you can effectively come in a virtual cave dive with me and my friends Phil and Rich. So there we go. And I really thought at the time I was just going to talk about 360 film, and I forgot that actually you can do it at the space store. So there you go. Look at that, perfect. Didn't even know it. And here's a little example, say, of the exploration in the UK again. Like, just get a chance to see that a little bit better if you can. That's me squeezing through a very, very small space in a cave called the Cave of Skulls in Appin. And even there, even the UK, and myself, my friends, and other people around the UK have got projects ongoing exploring underwater cave systems in Britain. And it's not just caves, but in a similar vein, we've got some phenomenal mine systems. A lot of the mines, years ago, like this one in Finland, were abandoned, and the lower parts were then flooded with the groundwater. So you can go to these again. These are these completely weird alien places, and really see what it would be like to visit a kind of abandoned alien city. And I think a great example of that is one out in Finland in Iamo. I'm going to keep covering the light just to try and get you be able to see this a little bit better. Is in a place called Hell's Gate. I'm going to show you this clip from a film that myself and some friends from the UK and Finland filmed a couple of years ago called Dive Odyssey 2018. It's a beautiful little kind of abstract film, only 10 minutes long. Go on Vimeo and look for Dive Odyssey 2018. And, it looks like a high budget sci-fi film, and actually it was filmed by a lot of friends in a flooded mine in Finland on an absolute shoestring. Let's have a look at a clip from that. And again, that you can do exploration or at least rediscovering these places. I've been in mines, even here in the UK, that have been abandoned and no one's been in for like 80 years. And you go down to the depths of these flooded chambers where men used to work and walk. And you'll find tools, boots, teacups. I've even found graffiti on the wall from 1938, the last day the mine was open. So you can find some. So underwater exploration isn't necessarily just about, about wildlife and about geology and science. Sometimes about history, archaeology, as we saw the shipwrecks, and even on land, with them not in the sea, there's still history, tantalizing real history to find. And the final thing I want to say is about a snorkel. Just turn that, give you a chance to look at that one. We'll go into the next one. So, do you see that? That's me snorkeling under a waterfall in Wales. But the point I want to make here is this. As I said at the start, the ocean, the seas, the lakes, the rivers, the amount of underwater world there is on this planet is immense. It's more than 7/10 of the total coverage of the planet Earth. And actually, taking the UK for example, depending on how you measure it, there's all kind of debatable, but roughly there's 25,000 miles of coastline in Britain. And we're a relatively small country. There are roughly 10,000 miles of rivers and between 8,000 and 10,000 lakes and lochs and llynns. And that's not including all the underground caves and underground mines that are flooded, and ponds and mountain pools and all that sort of stuff. and only an absolutely tiny fraction of that has ever been explored by a human being, by the Mark I human eyeball. And the vast majority of all that is only a metre or two deep. So actually, to be a genuine underwater explorer, to be a genuine explorer and go somewhere and see something that no one has ever seen before, actually, you can do it right here in the UK with nothing more complicated than a plastic tube with a snorkel. So, you know, people say, oh, so you're an explorer. And I say, no, I'm an underwater explorer. Because actually, to be an underwater explorer is pretty easy because there's so much left to explore. Ladies and gentlemen, that pretty much concludes us with 6:10. That's not too bad. I might have managed to ramble on a little bit there, but I think now we can bring back in the guys from Space Store and we can take some questions from you. So, yes. And I'm going to turn off the projector just so it doesn't make some less noise. Yes, there we go. Beautiful.
Awesome. Thank you so much. That was absolutely amazing. Some of the journeys you took us underwater, they were so crazy. We learned so much. We've actually had a very attentive audience today. We've got a few questions in already. And the first one's actually from an anonymous attendee.
Get some light in here, folks, just so we can you can see me a bit better. There we are. Good morning.
Awesome.
Right.
So an anonymous attendee asks, these are absolutely incredible and I'm truly in awe. Being an explorer and seeing the beauty of nature that not everyone gets to see every day. And the effects of climate change in any of the locations you've been exploring at.
So you slightly broke up there. Did you say that? Have I seen evidence of climate change?
Yeah, so have you seen the effects of climate change in any of the locations that you've been exploring at?
Well, I'd have to say that I don't return to the same place very often, and that's really what you need to really assess something. You need to be returning year on year. Certainly the scientists, the glaciers that I've worked with, they've seen it, and they've shown me pictures and footage of that glacier slowly receding, and it's, you know, by tens of miles. You know, where the calving front of that glacier is in Greenland is far further back, but it's far a smaller glacier than it used to be. I've got a very good friend of mine who his job, he's a polar photographer and polar scientist, and he goes to the North Pole pretty much every single year. And the photos and the stories he brings back is just, you know, it's pretty stark, pretty obvious. It's very hard to see a photograph of something that was like this big, and now it's this big, and then it's this big over the space of sort of, you know, 10 years. So I couldn't honestly say I've seen it in my own eye, because I seldom go back to the same place twice, which means, you know, you don't really get a chance. But the other thing I've got to bear in mind is friends who live in places like the Maldives, you know, and for those who don't know, the Maldives, a tiny group of islands, and it's basically, they're like atolls, they're little sort of coral islands. So you know, the highest point in Maldives is only a few meters above sea level. So again, it's not just there's an environmental impact and a wildlife impact, you know, with us losing this habitat, you know, in the polar regions, but also it's the sea level rises that are happening, which is affecting people more around the equatorial regions, wildlife and habitats going, but also people being displaced by these rising tides. And then obviously you've got to remember that it's all linked, and this is something I probably didn't appreciate as well as I should have done, especially having a degree in zoology. But everything, you know, there's a calving iceberg off Greenland, and that affects the weather in the UK. It genuinely does, you know. So the more icebergs that are created because of global warming, there's a change in sea patterns and currents, and that affects weather in the UK, which means that it might rain on your barbecue in the middle of July. But more importantly, it means that in the Sahara, there's an increase in desertification, either the unnatural growth of that desert, which again is killing habitat and villages and wildlife. So, you know, yeah, I mean, I'm well aware that this exists, and the impact isn't just happening at the poles; it's happening everywhere, including Britain. You know, we're seeing it here.
Awesome, yeah, thank you. We've actually got a mine explorer watching in,
Cool.
Helen Pemberton. And she asks, how does the present preservation of the mine artifacts underwater compared to what you can see in the non-flooded mines?
Much better. I mean, from an archaeological point of view, preservation of organic materials is always better underwater, especially actually more so in fresh water and muds. I've been involved in a few archaeology projects for Nottingham University, in some in fresh water and some in seawater, but in the fresh water, especially in the UK, where the water is quite muddy, the organic preservation can be phenomenal. Again, especially in cold water, like up in Scandinavia, they've found, you know, pretty much preserved wooden shipwrecks, and I mean like 95% preserved medieval shipwrecks or Viking shipwrecks in rivers that are pretty much 90% intact. So there's that, and then again, the deeper you go, the colder it is, the less oxygen there is, the less light there is, the less biomass of life there is, and therefore again the preservation tends to be much better. So I mean, Britannic was phenomenal. So it depends really where the thing is. In mines, especially, because how mines tend to fill up, like caves are usually underwater rivers. There's usually a slight, at least a slight current, or when it's raining hard, a huge current. But a mine, it's the water table. So people dig down, they dig below the water table, the mine floods, they pump it out, and then once they finish, they turn the pumps off. What happens is very, very, very slowly, the water just trickles back in. And it doesn't disturb anything, it doesn't smash anything up. So, and there's not really any wildlife down in a mine either. There's no really any organisms. So yeah, we found pickaxes and pickaxe handles. I found old leather boots, tin cups. So there was graffiti on the wall in that mine in Wales. It was just written in charcoal, really, but it was still there because again, there's no water movement to kind of wash it off. So yeah, certainly the underwater archaeology has a huge part to play in kind of showing us things that would never crop up with terrestrial archaeology.
Yeah, I mean, as you said, like when you go, you rarely visit the same place again, and I think that's the same for most underwater explorers. Once they've been to one place, they don't go back to it again, and it kind of strengthens that preservation of whatever's left there is left there forever.
Yeah, I mean the caves pretty less so, because in order to get to the end of a cave, you've got to continue. You go in, you explore so far, you come back out, then next year you go in a bit further and come back out. But I mean, caves are very robust environments. You know, there's not much we can do to damage a cave. I mean, it's a naturally made rock structure. You know, you've got to be very careful if it's been once upon a time a dry cave, because in dry caves you can get things like stalactites and stalagmites and straws, these amazing, fragile, beautiful geological formations. If the cave has, and that's like Mexico or Bahamas, are really good examples. Lots of caves there that were once dry, so you've got stalactites and stalagmites, and but then sea level rise, which is a natural process. It's just now has flooded the cave. So as you dive through, you've got to be very careful not to damage the rock structures. But certainly caves in Europe, like caves in the UK, caves in France, for example, these are just big, robust limestone tubes, basically. So, you know, heavy inverted commas. I mean, you don't get that many cave divers, but heavy cave diving traffic doesn't really, hasn't shown any problems.
Yeah, I mean, speaking of caves, Ryan Atkin, welcome Ryan. He asks, where was your favorite cave that you dived in, and which was the most challenging?
Favorite's a hard one because they're different. You get some huge caverns, massive drive bust down, and the other ones are super tight, but still like really interesting because you've got crawling through them. And the Cave of Skulls up in Scotland's got a special place in my heart because I did that about 10 years ago, and that was my 11 years ago now, but that's my first proper kind of little exploration project. I wrote some articles on it. I made a little film for the BBC, and it kind of kickstarted a lot of what I'm doing now. But the most challenging ones were easier, and that wasn't actually a cave, but it was still cave diving. It was that mine in Finland, because and the problem there was not that we're diving deep, which we're diving sort of 90 meters deep, which is fairly deep. You know, you're on mixed gases again, rebreathers. The fact we're inside the mine's about sort of 500 meters inside, which again isn't that far in compared to what I've done, but it was so cold. So the water inside the mine was 2 degrees Celsius. And then you come out of the mine and to decompress, you're in a lake, a freshwater lake, and you get this reverse thermocline. So the shallower water is actually colder. It's basically 0 degrees. So you're smashing the ice to get in. You dive in, you go into the mine, you do a long dive. You've then got maybe 2 hours of decompression to do hanging in this 0 degree water. And at the end of that dive, you've got to take one of your cylinders off and smash the ice to get back out because it's frozen up over top of you. And to combat, I mean, you're still hypothermic when you get out, but to combat that, you've got like 4 pairs of gloves, 2 hoods, 3 undersuits, you got this bulky kit on, you can't really move in. It just makes it hard work. So that was probably the most challenging dive I did. But very satisfying because of, well, 2 things. One, because the underwater landscape is just, it is like being in a science fiction. It's like being in you know, like an Aliens film and Prometheus. Everyone thought it was like being in Prometheus. But also the guys, because in those sort of environments, there's no capability for complacency. You've got to bring your A game. And you know, we're diving with some of the best cave divers in the UK and Finland, so some of the best cave divers in the world. So that made it pretty special.
Oh, it's fascinating. It kind of leads us on perfectly to Freddie Holding's question. Hi, Freddie. Actually asked, how did you train with all the amazing equipment?
Slowly and thoroughly. So these sort of things aren't. It's pretty binary, you know. Cave. Like I do climbing and skydiving, and you know things can go wrong climbing and skydiving, and you can graze your knee, twist your ankle, break your leg, break your back, be in a coma, die. You know, there's a kind of graduation of increasingly severe, you know, outcomes. Whereas in cave diving, no one really gets injured cave diving. You kind of, it's pretty binary. You either come out okay or you don't come out at all. So there's no room for kind of rolling dice, gambling, or being complacent. So you know, you learn to use the equipment properly and well before you start cave diving. Certainly, if you want to have a long career in it. So I started snorkeling as a kid, and then diving when I was a kid, and then I was a diver in the army as well, and then moved on to rebreathers. And I've done thousands of hours on various rebreathers, both cave diving and doing very deep diving in the sea. So yeah, you know, it takes a long time to build up the experience, and you've got to build it up slowly. There's not really any shortcuts. You can't there's no crash course for this sort of stuff. And it's less about being good when everything's going fine. Yeah, you know, I could take anyone, put them in my kit, take them underwater, as long as nothing went wrong and they didn't panic, bring them back up and be fine, you know. Also, everyone's a good diver when things are going well. Yeah. The trick is to still be a good diver when things are going badly. That's where experience counts, and you need to keep a level head. So yeah, there's no fast for this. You just gotta and people say, "Well, how long does it?" I don't know how long it takes. How much you've got to do, I don't know. It's different for different people, you know. Yeah, but I've been diving now, formally diving for almost 30 years.
I mean, you mentioned rebreathers, and Ryan Atkin asks, do you prefer using rebreathers or open circuit? I'm not a diving expert, so you might need to explain what each of those means to the audience.
So yeah, open circuit is scuba diving gear. Scuba gear, it's what people tend to think of when you think about diving. Basically, you've got a big tank of compressed air, it's called air in your back, and you breathe in, and then you just blow that bubbles in, and you know, once you run out of gas, that's a dive over, hopefully on the surface. A rebreather, as I mentioned, it recycles one breath. So you breathe out through this one tube, and it basically goes into this stuff that looks like cat litter, and that absorbs all the carbon dioxide, and it comes back round, and you breathe it back in again. And you've got a few little bottles that just inject tiny 10 minutes of oxygen back into it, just to replace the oxygen your body metabolizes, but it's like tiny amounts. So, you know, a unit like that, it depends on the temperature of the water and everything else, but a unit like that will last you 3, 4, 5, 6, 7 hours underwater, and that's regardless of depth. Whereas open circuit scuba gear might last you an hour, but that decreases. The deeper you go, the less time you have. It will be used up quicker. But it's horses for courses, really. So a lot of the cave diving in the UK is short sump. So it's short underwater passages followed by long dry passages. You know, because the cave kind of goes up, is dry, wet like that. And it's much easier to move scuba gear through those sort of places because they're shallow and short. You don't need rebreathers. So, you know, even I use snorkels probably as much as I use rebreathers, to be honest. So what I always do is I look at the dive, like what we're trying to achieve here, what's the point of it? Right, what's the best kit for the job? As simple as that. You know, you should let your objectives drive the equipment, not let your equipment drive what you do. And I always go for the simplest solution. So if I'm diving in, if I'm filming in 2 meters of water, or I'm trying to study a shipwreck that's only in 2 meters of water, like we did out in Greece one time, this sort of submerged town in Pavlopetri in Greece, was only a meter. It's the point of going all the hassle of prepping your rebreather, getting on. These things weigh a ton, diving it, having to strip it down afterwards and sort it out and refill it and blah, blah, blah. Plastic tube lasts forever, you know. So yeah, I look at the job and then decide what's the best kit for it.
Awesome, yeah. An interesting question now from Wojciech, I hope I've said that right. And he says, Andy, with all these extreme dives you've done, have you had any DCS symptoms? And if so, how did you deal with them?
Okay, so DCS is decompression sickness, where that's basically the bends, as people know it. So I've never been symptomatic. So, you know, the likelihood is that after every deep dive, you've got little bubbles somewhere in your body, but I've never shown symptoms of the bends. So we get by that, but that's the bends is what happens to people if they come up too quickly. So when you're at depth, like the Britannic, 13 times atmospheric pressure, gas is being forced into your body, just like it's forced into a bottle of Coca-Cola. So you get bubbles in solution. And as you come back to the surface, that's like shaking the bottle up when you're diving. And you get two choices: come back to the surface nice and slowly, and that's like just undoing the cap nice and slowly, let that gas off, and you're good. However, if you come back to the surface really quickly, that's like spinning the top off really quickly and it explodes everywhere. The actual physics of what's happening to your body and that bottle of Coca-Cola is exactly the same. So that's why we have to decompress. But yeah, no, I've never had a DCS, a decompression problem yet. You know.
I'm glad. I'm very glad. I think we have time for one more, and we're going to go for Ankomar's question. And he says, what's the worst accident or rescue situation you have encountered, if any?
I've been fairly lucky. I've had some people injured, especially in the forces, using the equipment and the sort of, we used to do underwater demolitions and bomb disposal and that sort of stuff. So, but the people that I operate with now, you know, are world class at the top of their game. And I said these are not environments for little mistakes. Mistakes tend to be either really big or insignificant. If I'm honest, most of the accidents I've seen in diving have happened on the surface. It's people, you know, tripping over, dropping things on breaking their foot by dropping a weight belt or a cylinder on their foot, or slipping on a gangplank and you know, going over. You know, underwater, things have always gone reasonably well. Or if they haven't gone well, we've had the equipment and the plan and the people to sort it out immediately, and therefore actually the outcome's been fine. You know, I've had helmets flood underwater on the forces, but again, I've had equipment failures. Equipment fails all the time, but again, we assume that that's going to happen, so we are super paranoid in the planning, and we assume everything's going to go wrong and at the worst time. When we're underwater, and we have plans in place and spare equipment in place with us to deal with that. So should your air supply, your regulator fail, we'll go, my God, that's going to kill you. Well, no, because I've got another one here and then another one here. You know, I've got like 2 or 3 backups. So yes, I've seen a lot of problems, but I've also never seen them roll on to become anything more serious than they need to be.
I'm glad. I hope it stays that way. And I think that is a perfect bombshell to end on.
Beautiful.
I'm really, really thankful to all of the audience who've stayed until this long, and I hope you guys really enjoyed this talk with Andy. Anything you want to say?
No, just thanks so much for coming, guys. Much appreciated. I know that it can be hard watching me bang on for 60 minutes on your laptop, so thank you much for staying with us. And yeah, I'm sure that the space have got loads more speakers lined up, so yeah, stay tuned for those.
We do, yes. Thank you so much, Andy. And thank you all for you guys who have attended. Hope to see you next week at 5:30 for another incredible talk. Until then, take care.